Hey everyone, welcome to the Spoon Podcast. I'm your host, Michael Wolf, and today's guest is one I'm really excited about because we are going to be talking about some really cool stuff, the future of cooking, 3D food printing, laser cooking, and software-defined cooking, all those cool topics that I love to get nerdy about. We'll be talking about today with Jonathan Blutinger, who is a researcher. And I first ran into Jonathan's work when he and a group of students at Columbia University published a research paper, I think it was about 2 years ago, on cooking with lasers. Yes. In which they cooked a chicken, which I thought was pretty cool. And since that time, he's been focused on things like 3D food printing, using software to help guide the cooking process. And, Jonathan told me during this interview that one of the things that inspires him was that unlike many other spaces, software hasn't really invaded or overturned the world of cooking and food like other spaces. And so he started to explore software-defined cooking, things like 3D food printing. And he thinks that this technology could really uncover some interesting opportunities in the future. And what those are, we talk a little bit about. So you're going to have to listen to the podcast to find out. But before we do that, I just want to remind you that you can find other Spoon podcasts at our website. Just Google The Spoon. We're always the first result. And you can find out more about Jonathan Blutinger's work at The Spoon as well. So go check it out. All right, that's it for now. Let's get to the show. All right, today we have a guest to talk about one of my favorite nerdy subjects in the world of food tech, and that is 3D food printing. And Jonathan Blutinger, thanks for joining us today.
Awesome. Happy to be here.
So we connected, I think it's 2 weeks ago or so. We had a mini virtual event on the world of 3D food printing, and you presented some really cool stuff. But before we get into some of your research, tell us a little bit about yourself. How did you get into this world of 3D food printing?
Yeah, if you had told me 10 years ago I'd be working on this, I'd say you're crazy. I first kind of got started with this. I learned about the kind of work that Hod Lipson is doing at the Creative Machines Lab, just from actually perusing Facebook one day. I was looking for PhD programs, and like anything else, I saw a cool video, opened it, and he was talking about self-aware robots. It was a TED Talk. And I remember seeing this and thinking, wow, this is super cool. This is like right up my alley. It seems like a cool field to kind of get involved with. And then I saw he had, a recent book he published on 3D printing, mostly towards food applications. And I was like, wow, this is so weird. I cook a lot, it's something I'm super passionate about, but how could you actually print with food? So I kind of kept following up with him. And the next thing I know, I got to Columbia, and then I realized it was a project that was open. At the time there wasn't a PhD working on it, so I kind of just jumped in, and I mostly got involved in the cooking side. But first thing he told me was, you got to make sure you're really behind this because it's a very controversial topic, and you're gonna get a lot of pushback. So I don't think I realized what he meant by that until now. But that's kind of my journey thus far.
And I want to dive into that pushback a little bit. I mean, certainly it's like this foreign concept. I think anything different from what we're normally used to, just putting something in a microwave or an oven and putting it on our plates, like consumers of food just almost instinctively are creeped out by it. Anything that you might read about in a science fiction book, like that's actually happening in real life, kind of freaks us out a bit.
Totally. And I think people are, I'd say, more emotional about food than anything else. This might be a hot take, but I think people are more emotional about that food than they are about religion or politics in certain ways. Like you go to a restaurant, everyone has their own little thing they have to change on the menu. I see this when I go out to dinner with my family, and it's like everyone's got their little tweak, and I know my order's gonna get screwed up by the end of it. So, because we're only human. So I think there's a big emotional tie we have to food because it's our sustenance for life. So it's important that we intake what we want. We all kind of have our own little particular needs. So as I was thinking about it more. If you have a machine that can kind of do this all for you, and it's not a human that can kind of make mistakes, it can learn from you, it can start recommending things for you, and that's kind of where it kind of set things apart for me.
All right, so sounds like you were post undergrad doing some kind of research, and funny how Facebook actually served a useful purpose in your life. Seems kind of out of the ordinary at this point, and you decide to go into this program, and you dive into it. And what was the learning curve like? Were you getting your hands dirty a lot, actually trying to print food? Were you searching out chefs who were maybe doing this in their kitchens, in their back of house? How did you dive into this?
Yeah, so it's funny. I actually didn't really work at all with the printing side until maybe a couple of years in,
Hmm.
because that had kind of been prior art at the time. There was a student who was working on it prior to me, Jeffrey Lipton, who kind of spearheaded this research initially, and then someone before him. I kind of came in with a new topic, which was mostly the laser cooking. So I devoted most of my first couple years characterizing lasers for cooking, since it had never been done before. Prior to that, if you had searched on Google, you would have found like one little bit of research from a
Yeah.
Japanese research lab that laser cooked bacon. So it was a good blue ocean to kind of explore. So I jumped into that part, and then the eventual intent would be to incorporate this laser cooking with the food printing because of the resolution you get with cooking with a laser, and also just the penetration depth of the heat, which is really ideal for layered assembly, especially for food. So towards the end, I kind of started to combine them both together, and then we started to look at what kind of recipes can we create, how can we kind of push the envelope as much as we can.
And so the thinking is, laser based cooking is something that pairs well with the printing of food. Because, I mean, a lot of times, what you're going to do in this future that we're thinking about is you're going to actually print it layer by layer, but you're also maybe within the same appliance, same device, you're actually cooking it simultaneously. And is lasers the best way to do that?
Yes, I mean the way I think about it is, cooking the way we're used to right now. It's pretty low resolution, but you can cook faster. It's more efficient for the type of cooking we're used to, which is cooking with our hands. A lot of items and recipes and things have been designed for the cooking appliances we have. So you take a pizza, or it's optimized for a brick oven for high temperature heating for low time. But when you take a laser, it's a totally different way to cook because you can cook on a millimeter resolution. So it's like having a little oven that you move around on your actual apply on the actual food, and you can kind of raise or lower the temperature of every little voxel of food, every three-dimensional pixel, if you want to think about it that way. And so you can really dial in the type of cooking you want on every little portion of your food, which right now it's hard to think about because you're like, okay, I just want my steak cooked medium rare. Like, why do I care about having every little voxel controlled? But let's say you wanted a steak that was medium rare, medium well, like you had a little checkerboard pattern, and you can control the
Yeah.
texture, the flavor, like everything becomes so local. So it really kind of changes the way you think.
Or maybe another way to think of it is if you're cooking like a pastry with like a soft, creamy inside, and then like a bread around it, you can print out that middle part separately from the bread part, and like you're not cooking that middle part.
Exactly, yeah, like a lava cake, where it needs to be cooked on the outside and then the inside kind of stays liquid. So it really kind of took me a while, I think, to kind of rethink what we're used to eating, especially for these appliances. But I think like any other new technology, there's going to be a learning curve, especially with the kind of things that you're able to do with it. So my intent at the time, and still is now, is to just let's push this forward as far as we can. Let's try to show people what's possible with it, and then obviously people like yourself, like you're suggesting right now, will come up with their own ideas of things they could use it for, and it'll kind of find its way slowly.
You worked on a paper, I think, recently published called Software Defined Cooking. And when you think of like a printer or just a piece of hardware that's working with a material, like there's three or four components to it, right? There's the actual physical hardware, which is a 3D food printer. There's the software which controls the whole thing, and then there's the materials. And so, in a way, all these things need to come together for like a 3D food printing system to work. And the software part of it, the control layer, the user interface, that actually is largely undefined. I mean, you have software to kind of do 3D printing, right? Hey, run my MakerBot.
Yeah.
But to do something to make a meal, that is something that like you're thinking about, but that doesn't really exist in large part today.
Yeah, that's a great point. It doesn't. And what we're doing right now is we're using existing engineering software that's really used for designing industrial parts. So, plastic, metal, mass manufactured parts. But when you're printing with when you're creating food using additive manufacturing, you really have to rethink the way things are assembled, and it allows you to do so much more in terms of design, which current design software does not accommodate. So what we've tried to do is, create our own software, but we realize, we don't have the resources of a large company perhaps, it's a little difficult. We ran into some roadblocks, so we're still using existing software, but I think that's crucial. There needs to be like a food Photoshop, so to speak, where or a CAD or design software where you can actually realize the ingredients and the things you want to make. And it has to be user friendly. That's the thing. Like right now, we're all engineers. I have computer scientists, I have mechanical engineers, but no, I understand not everyone has this kind of coding or this kind of background, and usually software can kind of scare a lot of people. So it needs to be something for the masses. It needs to be understandable, and it needs to be user centered for your mom, for your son, for your grandmother, like for everybody. So that's kind of what we're trying to develop too.
I mean, the traditional way we think of like food is art. We think of the chef who's spent a lot of time honing his craft in the kitchen, maybe has a pretty good idea of how different foods react at different temperatures and whips up this innovative creation. But this completely turns that on its head. It's a different form of craft using software. So maybe like in the future, there might be chefs who are largely sitting in front of a screen using a digital creative tool, like you said, Photoshop as an example, and creating like this futuristic meal that goes on our plate.
Exactly. I think there's a lot of analogies that can be tied to the music industry, where you have, your high-end creators who are the artists we listen to on the top 40 charts. And then you have, the producers who are in their garage or, developing things in their studio, all on a computer, right? They don't even have to have access to instruments or know how to play instruments to be able to create these, wonderful songs or masterpieces that we listen to on a daily basis. I think it'll be the same thing for food. Once this software exists and this ecosystem is developed, you'll have the people who are purely the creators and then purely the listeners, and maybe people who do a little bit of both. But you don't need to be a chef to be able to make the food you want in this futuristic world where we have machines doing it. We have robots doing it for us. So I think that makes things super interesting, and it kind of changes the way you think about it.
Yeah, you framed it. I like the way you framed it when you presented earlier in our event last month. You talked about the music ecosystem and compared like the printer today to like the iPod. We don't really have any music or MP3 files. So we're kind of circa 2001 or maybe before that, maybe somewhere in the 90s at this point. Mm-hmm. And we really don't have this ecosystem built out to actually listen to music or, in other words, print food.
Exactly. Yeah, I think that's a nice analogy I like to use. And I think it's very true. We've developed the hardware, but where's your iTunes store? Where's your music library to actually choose from? I think that's one of the issues that a lot of these commercial food printing companies are running into, which is, they have this awesome machine, it can print with a couple of ingredients, but they need to still have a lot of, they need to have a constant applications engineer working. I imagine this is how they have to do it, which is they have to have almost a support agent who's constantly helping kind of bring the chef along if they're using it for their application and really customize it for them. But wouldn't it be nice if the chef could actually do it for themselves? So I think that has to happen, and it will happen. I think as we're understanding this technology and figuring out its place, maybe we don't totally know yet all the types of technological tasks or pieces that the robot will be able to do for us, and that's a crucial part to developing this like food API, so to speak, and way for the machine to actually standardize the recipes we give it. I think that's important.
When I first got a MakerBot, I think it was like 10 years ago, it seemed like all you could print, the average person who got their first 3D printer was these little plastic figurines. And so it was like the materials was fairly limited. And I feel like with 3D food printing, that's kind of been the case where it's actually been used, I think, in any sort of like culinary scenarios, largely been doing things like printing sugars, right? Because chocolate's actually really easy to make some kind of cool looking chocolate creation. You're not seeing necessarily some chef on any wide scale making this really great cake with lots of different frostings and et cetera. And so if we think about the ecosystem, the materials science of it, where does that going? Like, are we going to get cartridges with like things like building blocks for meat, building blocks for like pastries? What does that look like now? What's it going to look like?
The way I see it is you're going to have a robot that basically has as close to the base ingredients as possible to make most of the foods we eat. So what I mean by that is, instead of having dough, you would have water, maybe flour and yeast. You would have as many base ingredients as you can, whether they're in a liquid, a powder, a paste form. Ideally, this machine is going to be something that will be able to accommodate any type of material. So right now it's mostly working. The easiest thing to work with is paste because it's just easy to flow. It holds its shape. So we're a little constrained to the rheology, but we're working to develop new ways to actually dispense different types of ingredients. And it's not a new concept. I think in mass manufacturing, there's ways to handle all different types of food. So slowly it's going to get into a more form factor and kind of a more consumer level. But I see this as a machine that can accommodate a bunch of different ingredients. And again, because it's digital, there's a whole shareability element too, where you can pass these ingredients around, have these developer community, and it will kind of tie into the whole IoT, Internet of Things that we are now connected with, where Alexa listens to your watch, which listens to your phone. Like it just makes total sense to me. And I think this environment will start to kind of pervade a little bit more and people will start doing fun things with it.
As I followed the space, it seems like the liquids world is a little bit ahead of the food world. Obviously, it's easier to dynamically mix building blocks for beverages, as an example. So we've talked about Canna before on this podcast. Mm-hmm. There's another startup out of, I think, Belgium doing what they're calling a beer printer. And, these companies actually haven't pushed out mass produced products yet. So we'll see how that actually moves towards market. But it does seem like, at least with beverages, like with the Canna, for example, they've been able to take different components of what actually adds to the taste of a drink. And they say that their drink printer will create colas and alcohol and cocktails and coffees. And so it seems like that's maybe easier than what we're talking about with what you're looking at for food.
Yes. I think another thing that's maybe not talked about enough is the connotation behind it. I think, when you're thinking about liquids dispensing, it's probably people are more okay with that because they've been to Starbucks, they've been to these other kind of more commercial chains where there is that sort of thing already. You can go to a dispensing machine and just kind of put your cup underneath of it, Coke will come out or Mountain Dew or something else. But if you think about that with food, it kind of makes people kind of pause for a second. So I think one of the reasons why you're seeing, chocolate printing, you're seeing cake decorating robots that are fancy is because sweets and confectionery things people are more okay with that. Savory products are perhaps people pause a little bit more. When you think about printed chicken, I know we had a paper that came out like 2 years ago at this point, and we printed chicken and we laser cooked it. And I had a feeling, I'm like, okay, this is definitely gonna get some pushback, but we want to kind of show what the technology can do, so we have to do it with a meat product because you have salmonella, you have other bacterial kind of considerations you have to consider. So if we can cook meat, we can pretty much cook anything. So that was our intent, but obviously, after you publish something like that, you're like, okay, this is gonna get a lot of pushback. People are gonna be like, what? You're laser cooking chicken?
Yeah.
And we even got popped on Stephen Colbert, which was funny, and he was roasting us at the end of his show. So that was a fun moment. At the end of the day, any publicity is good publicity, but there definitely is this pushback that is innate, especially with savory products, because people don't expect it to be looking in this perfect shape. So it has to look organic and stochastic in certain ways. So it's difficult.
But today there are a number of startups that are actually and have gotten venture funding for 3D printing of food. Some of that is plant-based, completely plant-based. Some of that is a mixture of cell cultured cells from animals and plants. There's the company out of Spain that we talked about. I think you're working at the company that also is doing something similar. So we're kind of at that point where it's gone from experimental paper on Colbert to actually companies getting funding to bring this to market.
It's true, and I say that as more of like a joke, but it's true. I think because it's so new, like certain people are seeing the future and the vision of it, but I think it's still okay to me that I think there's a lot of pushback because that means it is so new and innovative that naturally people are kind of irked by it. So that also is what kind of drives me, I think, through this process. But yeah, like you mentioned, there are a lot of companies that are getting funding for this, and I think the plant-based meat realm or application of 3D printing is one I had never really thought about, but it does make a lot of sense. If you think about a machine that can print these lines of food, then those lines become muscle fibers in a cut of steak, and then you can control the marbling, you can control the texture, everything locally. And that's actually what part of my research was during my postdoc. It was kind of a little bit 3D printing, a little bit food printing, but also how do you characterize, the texture and the quality of these different steaks and qualify them, and how do they compare to the real thing?
Another question you might get from people is like, why? Like, why are we doing this? I mean, it seems works pretty well to have a butcher cut up the meat, a baker to bake cake in an oven. What are the reasons you would say we need to maybe look at using 3D printers for food?
Yes, it's hard to see it solving a problem right now. If you think about a lot of new technologies, usually it's like, oh, there was a clear problem, we're solving it. This is less, I think, about solving a problem and more about creating a cool opportunity. If you think about software touching a lot of different industries, whenever software kind of invades a domain which was previously analog, it just totally converts it into different verticals that we never thought possible. So I think about this with telecommunication, right? We used to have, if we're going back, years, I'm not even sure when the last rotary phone was, but communication was fine up to a certain point. And then we started getting into digital technology, the Nokia phones, which are really stable and functional. Then the iPhone came out, and it just allowed people, I'd say what it kind of allowed people to do is, as soon as you kind of brought in this FaceTime element where, people were like, oh, it's a cool phone as an API. You can talk to people from long distances better, but now you can actually see them and like be there in the same place, especially like Zoom calls, that sort of thing too. It's like, it just creates all these new opportunities. Like, oh, now I can like see my friends across the world without actually visiting them. So I think this sort of thing, I don't even know what it's going to be like for food. We're conjecturing here what it's going to look like in the future, but the truth is we don't know. Like, I think people will create their own little environments and worlds, but the way I see it is software, it invades an industry, totally transforms it. This hasn't happened for food, so let's try it and let's see what happens.
In a similar industry I follow, the radio power kind of cooking side of things, there's been a new technology called solid state cooking that's been slowly percolating. You've had big appliance guys look at it. There's an industry association that's trying to kind of develop standards for it. And I think Miele in Germany actually created a super high end oven it's basically the next generation microwave. It uses radio waves that you might find in our cell phone and does high precision cooking of like a region, so you could cook meat on one part of your cooking chamber, starch in another, and then there's this software feedback loop that kind of knows, hey, it's done. It'll tell you when it's done using software. But this has really gone nowhere yet, even though it's vastly superior to microwave, which is really a 1940s technology. Yeah. So it kind of just speaks to the uphill battle a lot of times in kind of getting both the equipment makers who are used to the status quo. They can make stuff for cheap in China or Mexico, and they're just used to selling these things. And then consumers, they're used to buying the microwave. So it's just, there's a lot of different like hurdles that I think you have to get over for something completely new like this.
Totally. And I think there's no fast way to do it. I think it definitely is it's a slow transition. I think about this with, I've mentioned the music analogy, but I kind of like the analogy of driverless cars too. Cruise control has been something that we've been able to use ever since I was young. I remember, you could use cruise control. That's a form of, driverless car, right? Because it's controlling just the speed, obviously not the direction. But slowly, this like pervasion of driverless vehicles is slowly, like, I remember when I was in high school, we had a car that could actually park itself. The early BMW models would actually be able to do that. And then now we have cars that are literally driving themselves down the road on the highway, and it's totally hands-free. So I think that's a pretty crazy leap that if you look, over a 30-year, 20-year time, how look forward, it's like, wow, cars are just going to drive themselves. That's crazy. So I think that sort of thing has to happen. It's slowly happening with food. We're starting to get more comfortable, I think, with robots, flipping burgers for us behind the house, or, it hasn't really pervaded too much into our direct kitchens, but more so in restaurants and maybe like 1 degree of separation further from the kitchen. But these appliance companies that are creating these innovative things, like this cooking appliance you mentioned, I think part of it is just it's a little bit too new, but it's also how can you market this and suit it up into something that is attractive for a customer. I think about the air fryer example. It's just an oven with a faster speed fan in a more compact environment. So, but they call it air frying, and it sounds like a whole new technology. So I think it's a part of it's marketing, and part of it's also how can you contextualize this for people.
Yeah, I mean, both the Instant Pot and then the air fryer were both just digitized, more digital versions of what came before it, right? I mean, the Instant Pot is just a pressure cooker, and then the air fryer is convection. But yeah, you said miniaturized, and usually kind of a different interface on the front, goes on the countertop. And you and I nerded out before we were talking about the show Upload, and like the idea that scene where they actually show the guy printing out the Jamie Oliver hamburger on his, I think, his Samsung Google food appliance.
So many buzzwords.
Yeah, but I think the year of that show is set in 2030. So we're kind of 2023. Like, can we achieve that reality in 2030?
I think so. I mean, I like I said, the technology's here. It's obviously here is like, you know, in quotations, like how far can we push it? There's definitely there's further to push it. But, you know, just the other day we just finished doing like an 18 ingredient print. You know, the most recent paper we did was 7 ingredients for this cheesecake, and that kind of was the new record. But now we have 18 ingredients in one singular print. And really the only hindrance right now is the software piece. Like the hardware, it can all accommodate this. That's really what's missing is the software piece, which is usually what we're causing most of our issues when we're doing these prints is like, you know, some little piece of the code's off and it'll run into itself. Or these machines are only as smart as the coders that make them. So I think that's a big thing that'll be a push. But yeah, I mean, I think it's a fun world and something that I'm really looking forward to. But obviously, it sounds like the sci-fi, you know, Amazon Alexa, you know, developers for these movies are thinking about it too. So it's hopeful to think that they see a future with it as well.
You currently you have been a researcher at Columbia, and you're also straddling a little bit into the commercial side. You're working with 3D printed meat, advising a company there. Tell us a little bit about your current work.
Yeah, so my current work, so the company that was funding my postdoc, which is working on this kind of texture analysis development of their product, is Redefined Meat, and they're based in Israel. They're a plant-based meat company that's already has a lot of products on the market, mostly throughout Europe and predominantly in Israel as well. They slowly are making their way into the US, but not quite yet. So I'm working on basically creating a machine and a platform to kind of test bed their product versus the real thing, because if you think about it, there's no real like digital blueprint for real steak or real meat products out there. So they kind of wanted a way to qualify their product versus the real thing on like an actual numbers basis. So how can we actually quantify the texture of their meat versus the real thing, and how does it stack up? So most of my research was around that, and also just kind of supporting them in other ways. But yeah, it's been a fun collaboration, and I'm still kind of working at Columbia through that. But yeah, that's kind of where I'm at currently.
On these multi-ingredient prints, are you doing the cooking simultaneously, or is it you're just coming out with a raw piece of food and then it needs to be cooked elsewhere?
Yeah, it's a mix. Sometimes we'll have to. I want to try to work with only raw ingredients, but sometimes it's difficult, especially for vegetables, because of the fact that they have such a high water content, and when you blend them, even with a Vitamix or a really high-powered thing, you don't really get the texture that you need. So sometimes we will cook them first and get them into this more soft form that's easier to print. But again, that's kind of a limitation of the cooking appliances and the equipment we have in our lab. But yeah, so it's a mix. We can also cook it during the actual print, but it's all in situ. So it's like we'll print, we'll cook. Since the cooking appliance is on the machine, it makes it easy to do both at the same time. That's another thing that current food printers don't have. So that's kind of a nice thing that allows us to kind of cook savory things and print them at the same time.
All right, Jonathan, this has been great. Where can people find out more about what you're working on?
You can follow the work if you go to the Creative Machines Lab and you look at either digital food or laser cooking. We kind of try to update that as we're coming out with new things, or my personal website, jonathanblutinger.com. I try to keep that up to date too. And just doing fun things in food, and got some nice little videos and pictures there too.
All right. Well, let's schedule the 2030 version 2 of this podcast, and we'll see where we're at
Let's do it.
Based on our predictions. All right, Jonathan, this has been great.
Thanks so much, Mike.
So what do you think? Do you want a 3D food printer in your house? Can it sit on the counter like a microwave oven? Who knows? Maybe in 2030, 2035, that'll be the case. And hopefully you'll think back to this podcast when you do have your brand new 3D food printer cooking up a hamburger by Jamie Oliver or whoever. Maybe it's not a hamburger. Maybe it's something else. Either way, I hope you enjoyed this. As always, the Spoon Podcast was brought to you by me, Michael Wolf, and The Spoon. If you haven't already subscribed to our podcast, do so in whatever app you're listening to us. And we will be back next week to talk about AI in food with a very special guest. So tune in. Talk to you soon.